Here we're going to talk about whether or not a number is evenly divisible by 2, 3, 4, 5, 6, 9, or 10. And this is going to come into use when we start talking about fractions and simplifying fractions, canceling, things like that. And so knowing if you can divide by one of these numbers with some shortcut rules will be useful to you in that. So you might want to write this down and maybe memorize some of these rules. And so I will say though, in order to use this effectively, you're going to need to know your basic multiplication tables and how to do some basic division. So here I'm going to go through each one of these, and again, this will become more useful once we go over fractions. So I'm just presenting the rules to you today. So for example, if we want to know if a number can be divided by 2 evenly, and when I say evenly, that means there's no remainder, right? So if a number can be divided by 2, well, if the number is even, then we know it can be divided by 2. So remember, numbers that are even are going to end in a 0, 2, 4, 6, 8, or 10. Those are all even numbers. So for example, if we're given the number 28, we know 28 is divided by 2 because it's an even number. You look at the last digit, if that's a 0, 2, 4, 6, or 8, then it's an even number. So we know 28 can be divided by 2. So this would be, 14. But here we're just trying to tell, can we evenly divide this? If you look at something a little bit more, complex, if we were looking at 5,926 and you wanted to know, can that be divided by 2? Well, you don't have to actually do the whole division. You just look at the last digit, which is 6, which is an even number. It's an even number, so we know that this number can be divided by 2 and there won't be any remainder. So 2 is fairly straightforward. Just look and see if it's an even number. For 3, we are going to take the sum of the digits and see if that is divisible by 3. So remember, sum of the digits means that you add the digits together. So let's say we had 126. Is that number divisible by 3? Well, we're going to add the digits. So the digits are the numbers here. So 1 plus 2 plus 6 equals 9. Well, right away we know 9 is divisible by 3 because 9 divided by 3 gives us 3. So we know that 126 can be divided by 3 evenly. If we actually do the division, we're going to get 42. But we don't have to do the division in order to just know the fact that we can divide it by 3. We'll take a number like 2,943. Well, here again, the sum of the digits, which means add the digits up, 2 plus 9 plus 4 plus 3, and you're going to get 18. And again, you should know offhand that 18 is divisible by 3. 18 divided by 3 is 6. So we know that we can divide this larger number by 3. If we take a number such as 421, can that be divided by 3 evenly? 4 plus 2 plus 1 equals 7. And we know that 7 is not evenly divided by 3. So we know that 421 is not divisible by 3 in order to get an answer without a remainder. Again, we'll show you the applicability of this when we start talking about fractions. Here we're just trying to quickly decide, can I divide this number by 2, 3, 4, 5, 6, or 9? So in 4, in order to find out if it's divisible by 4, we look at the last 2 digits and see if that's divisible by 4. So for example, 340. The last 2 digits are the 4 and the 0. So all you have to do is look at the last 2 digits. 40. Is 40 divided by 4? Yes, we know 40 divided by 4 is 10. How about 1216? Is that divisible by 4? Well, you don't have to go through the whole division. You just look at the last two digits, 1 and 6, which is 16. Is 16 divided by 4? Yes, we know 16 divided by 4 is 4. How about 897? Well, the last two digits divided by 4, 97. Is that divided by 4? No. If you do 97 divided by 4, you're going to get 24, but then you're going to get a remainder. It doesn't go into it evenly. So we know that 897 is not divisible by 4 because the last two digits, 97, are not divisible by 4. With the number 5, it's quite simple. If the number ends in a 0 or a 5, we know it's divisible by 5. 105, all you do is look at the last digit. It ends in 5, so we know it is divisible by 5. For example, 105 divided by 5 is going to give you 21. So there's no remainder, so that's what we mean when it's divisible evenly into it. Something like 310. You just look at the last, it ends in a 0 or 5, just look at the last digit. If that's a 0 or a 5, we know it's divisible by 5. So 5 is fairly simple, just look at the last digit. With 6, it's a little bit more complicated. So with 6, let's say we have 354. And this is going to be more useful if you have, some big, huge, long number. But for example, it has to satisfy both the rules for 2 and 3 up here. So 1, it has to be an even number, right? Because it has to satisfy 2 and 3. So 2 says it has to be an even number. So you look at the last digit, that's an even number, so it satisfies that rule. But then it also has to satisfy the rule for 3, which means the sum of the digits is divisible by 3. So if we add the digits, 3 plus 5 plus 4, you get 12. And that is divisible by 3 because we know 12 divided by 3 is 4. How about 98? Again, it is an even number, so it satisfies the rule for 2. In 3, sum of the digits divisible by 3. Well, 9 plus 8 is 17. That is not divisible by 3. So 98 cannot be evenly divided by 6 because it has to satisfy both of these rules. All right, for 9, the sum of the digits has to be divisible by 9. So let's say we have 3, 1, 8, 6. So again, the sum of the digits, which means you add the digits up, 3 plus 1 plus 8 plus 6 equals 18. And so we know that 18 is divisible by 9. So 3186 is also evenly divisible by 9. Another example would be 9, 7, 4, 7. You add the sum of the digits, you get 9 plus 7 plus 4 plus 7, and that equals 27. And we know that 27 is divisible by 9 because 27 divided by 9 is 3, so we know that this number is also divisible by 9. What about, let's say we didn't know, well, let's do 781. 7 plus 8 plus 1 is 16. And we know that 9 does not go into 16 evenly, so 781 would not be divisible by 9. And the last one is 10, and 10 is easy, just like 5, where if it ends in a 0, it's divisible by 10. So any number that ends in a 0 is divisible by 10. It doesn't matter how large it might be. So again, this is just giving us some basic rules to quickly be able to see if we're going to be able to divide by a number. And again, it will make more sense as we get into fractions, but it's something that you want to keep in mind as we move on to those topics.